Welcome back. Today we're going to go ahead and discuss Lesson 10.2 notes, tangent, secant, circumference, and arc length. Now let me go ahead and tell you what a tangent is. Now a tangent is a segment or line that intersects a circle in exactly one point. So over here, if we look, this is a segment that intersects the circle exactly at one point. So we're going to go ahead and call this segment here, or particularly this segment. It does, if I just look at this part of this whole segment here, segment CD does intersect the circle at one point. So therefore, that's an example of a tangent. Now, a secant is basically an extended chord. It's a line or a segment that intersects the circle at 2 points. So, looking at this picture over here, we have a chord, but it's basically extended, right? So this is what we call a secant. So segment CA is a secant. So let's go ahead and look at this. Angles of a circle formed by chord angles. So if we have chord angles, these angles are inside the circle. So I have a chord. Remember, a chord is essentially a segment where the endpoints are on the circle. So here's my segment, and those endpoints here are on the circle. And that applies to this segment over here because the endpoints are on the circle. Now, if we are going to find the measure of the angles, or perhaps we can find the arcs. Who knows if they're asking us to find the arcs. Let me go ahead and just label this 1, 3, 2, and 4. So I have angle 1, angle 2, angle 3, and angle 4. Now to find measure angle 1, this is the formula. Measure of angle 1 is equal to this arc plus this arc, all over 2. So this arc plus this arc, all over 2. So this is the measure arc AB plus the measure arc CD, all over 2. Okay? And basically, if we know what the measure of angle 1 is, we know what the measure of angle 3 is as well because, well, these angles here are what we call vertical angles. So measure angle 1 has to equal to measure angle, measure angle 3. Okay? All right, to figure out measure angle 2, it's the same thing. So measure angle 2 is equal to this arc, so measure arc AC, plus the measure arc AD, all over 2, which we can also find measure angle 4 because that's essentially measure angle 2. By definition of vertical angles. Okay? So I'm going to go ahead and make a note. Vertical angles here. And vertical angles here as well. Okay? Now, just want to make sure that I'm clear. If we have a chord angles, where the angles are inside of the circle, all you have to do is you take 2 arcs and then divide by 2. So let's go ahead and look at example A. Find x. So I have a chord and another chord The angles are inside. So let's go ahead and find x. So if this is the angle, then we have the intercepted arc. And that should be next to this arc here as well. So all I have to do is I say, okay, this is x equals this arc plus this arc all over 2. And x is equal to 214 over 2. And if I divide 214 by 2, that's 107 degrees. Okay? So if this here is 107 degrees, that means that this angle is also 107 degrees because of vertical angles. For B, we have, if we ignore these things here, we still have a chord situation. The angles are inside the circle. So I need to figure out x here, right? But if I do x equals, it has to be this arc plus this arc over 2. But notice that we don't have a number here and a number here. We don't know what the measures of those two arcs are. So I gotta come up with a plan. I gotta make a gameplay here. So, I see that we have the measure of this arc and the measure of this arc. And this angle is associated to this arc, and we can also say it's associated to that arc as well. So let's do this. I'm going to call this y. Okay, I'm going to call that angle y. So it's y equals 143 plus 175 No, not 175, sorry, 75. 143 plus 75 all over 2. And that's going to give me 218 over 2, which y is 109. Okay, so y is 109, right? So how do I figure out x? Well, if we recall from our earlier units, well, this here, we have these two angles that are stuck together, right? They are supplementary, or they form a linear pair. So these angles here add up to 180 degrees. So all I need to do, y'all, is 180 minus 109, which equals 71 degrees, which is just y, right? So this here, it's not y, this is x. This here is 71 degrees. Okay, so that's the play to make when trying to figure out B. Let's look at C together. Okay, so again, the angles are inside. We have a chord situation. Here's x, here's 97, and we actually know what this angle is. It's 110. So remember, it's the angle equals the arc plus another arc. Okay, those arcs must be adjacent to the angle that we're dealing with here, all over 2. Now, I'm trying to solve for x here. So, notice that we have a fraction. I got to multiply both sides by 2 in order for me to get rid of the number that appears in the denominator. So, let's go ahead and cancel those two 2's out. So, I have 2 times 110, that's 220, equals x plus 97. And I'm going to subtract both sides by 97 here. So x is 123 degrees. Okay, so this arc is 123 degrees. All right, there you go. That's A, B, and C. let's look at this. Angles of a circle formed by chord/tangent angles. Okay, so I have a chord here. Remember, a chord is essentially a segment where the endpoints are on the circle, and then we have a tangent where the segment intersects the circle only once, okay? So if the vertex of the angle is on the circle, as you can see right here, this is the vertex, then this is the formula that you have to know. Now, remember from the previous notes that if you have a circle and you have your vertex literally on the circle, right, this is what we call an inscribed angle, where this angle is half of the intercepted arc. And that applies to this one as well. Because if your vertex, so here's my, here's my angle, this is the vertex, you have to think of this as an inscribed angle. So suppose that we call this, suppose that I call this angle, I don't know, angle 5, and this is angle 6. Well, the measure of angle 5 is equal to 1/2 of that arc. So it would be 1/2 of the measure arc AB. Okay? And if you were to find the measure of angle 6, you would say, well, I need to call this, I'm gonna call this D, okay? So this is a major arc. We have 3 points here. To find measure angle 6, that is equal to measure arc ADB. All over 2. So measure angle 6 is equal to 1/2 of measure arc ADB. Okay? So let's find this. We have a chord and tangent. The vertex is on the circle, and I'm trying to figure out QPR. So measure angle QPR. So the vertex, again, is on the circle. So I'm going to do measure angle QPR is equal to 1/2 of the intercepted arc. So that is, what is that arc called? Measure arc let's see, PR, yes. Just want to make sure that I'm naming this right, because this looks like PR, but remember it's actually PSR, and this is my major arc here, so it has to deal with 3 points, but this is what I want. So that's our minor arc, because we're dealing with 2 points here. So measure angle QPR is equal to 1/2 of 148. So 148 over 2 is 74 degrees. And that's our answer. Okay. Let's figure out the measure of angle DEF. Okay, so this should have been measure arc DEF, okay? So I'm trying to figure out how long this arc here is, measure arc DEF. And, okay, well, this is what I only have. I know that this angle here is 64 degrees. So let's do this. Let's try to figure out how long this arc here is. So I have 64 equals this arc over 2. So measure arc FD over 2. Got to multiply both sides by 2 here. So that's 128 equals the measure arc FD. So this here is 128. And remember, this whole thing, the circle is 360 degrees, right? So this is already in red. That's 360 degrees, right? So I'll write 360 in red minus the stuff in blue. Minus 128. And that's going to give me 232. So this arc here in black is 232 degrees. Okay? So that is, so the measure arc DEF, so DEF is 232 degrees. Okay? Okay. Let's look at this. Angles of a circle formed by tangent and secants. If the vertex is outside of the circle, okay, so we have, here's our angle, and notice the vertex is outside of the circle. This is the circle here. Then you have to know this formula. It's really, really easy. To figure out this angle, I'm going to call this angle 1, so I don't have to write so much here. To find measure angle 1, it's equal to this big arc minus this small arc, okay? So let me write this. Big arc, or I should say, the angle outside is equal to big arc minus small arc all over 2, okay? So if I want to figure out this angle here, it's this big arc, so it's measure arc AD minus the smaller arc, measure arc BD, all over 2. Okay, again, it's big arc minus small arc all over 2. Okay, so we have here, the vertex is outside of the circle. We were dealing with 2 tangents. Okay. Again, the vertex is outside of the circle. The formula still applies. So I'm going to call this angle 2. So that would be measure angle 2 is equal to the big arc. So measure arc, let's call this V over here, because I don't want to say I don't want to say that this is XZ when this could be also XZ. So this is our major arc, and I don't want to confuse you which one's XZ, right? So let's call this measure arc XVZ minus the smaller arc, which is XZ, measure arc XZ, all over 2. Okay, that's measure angle 2. And then we have 2 secants. Again, the vertex is outside of the circle. We're dealing with 2 secants here. So let's call this angle 3. So the measure of angle 3 is equal to big arc, so measure arc QS, minus the smaller arc, measure arc PR, all over 2. Okay. So what have we been dealing with? We have the vertex inside of the circle, where I do the adjacent arcs all over 2. And then we have the vertex on the circle, basically inscribed angles. All you got to do is you take the intercepted arc and divide by 2 for this one. And now we are dealing with big arc minus small arc all over 2, where the vertex is outside of the circle. Let's look at this example together. Find the measure arc CD. Okay, so we don't have anything over here. We do have something here, and this is our angle. Now remember, it's the angle outside equal to the big minus small all over 2, right? So I do 56 equals the measure arc CD minus the measure arc CB, which is 95. And and then I got to divide that by 2. We're going to multiply both sides of the equation by 2. So we get 112 equals the measure arc CD minus 95. And if I have to add both sides by 95 here, that's what x is equal to. So 207 degrees is equal to x. Okay? And that's your answer. Let's figure out the measure angle L. Okay, so this is great. This is a little weird because we're trying to figure out this angle here, and we know how long this arc is, but we don't even know what this arc is, right? But what I like about this is that we're dealing with a tangent-tangent situation. So if this here is 102 degrees, right? And we know that a circle is 360 degrees, all together. It's basically this part plus this part, which is going to give me the whole part. So all I have to do here is do 360 minus 102 to figure out what's the arc in red. So 360 minus 102 is 258 degrees. So this arc in red is 258 degrees. So I can figure out what measure angle L is. So measure angle L is equal to big minus my small arc all over 2. And I don't need to multiply both sides by 2, right? Because this is essentially our x, the measure angle L here. So just go ahead and do the basic arithmetic. 258 minus 102 is 156. And then we have divided by 2 here. So measure angle L equals 78 degrees. Okay. And here is our last problem. We have our angle, we have our big arc, we have our small arc. So it's 25 equals big minus small over 2. I multiply both sides by 2 here. So that's 50 equals 110 minus x. And then if I subtract both sides by 110, I get negative, what do I get? What do I really get here? Here, let's do this. Wait, what am I doing? That's negative 60, which is equal to negative x, so x is equal to 60. Oh man, I can't do my arithmetic in my head. All right, there you go. So x is equal to 60. All right. Now that we have, now that I've taught you all the formulas, we have some other things that I have to teach you. The circumference, y'all, do you remember what the circumference is? It's basically the perimeter of the circle, right? So to define perimeter, it's basically the distance around the figure. But if you're talking about the perimeter of the circle, which is, we have, a word for that, that's called the circumference. That's the distance around the circle. Okay, and the two formulas that you need to know for circumference are 2 pi r, or c equals 2 pi r, sorry, and we have c equals pi d. Okay, now c represents the circumference, and r represents the radius, and then d stands for diameter. So it says find the circumference if the diameter is 8. Okay, so all I have to do is, since we're dealing with diameter, we should use this formula, not this formula. C equals pi d, and I'm replacing the diameter with the number 8. So C equals pi times 8, or I'm going to rewrite that as 8 pi. Now I'm going to leave my answer, in terms of pi. which means I don't multiply the pi whatsoever with the 8. I want my answer to be exact. So if I do 8 times 3.14, it's not exact, right? That's about the perimeter of the circumference. I want the exact answer. So C equals 8 pi is sufficient enough, if that makes sense. Here's this one. If the circle has a circumference of 24 pi, find the radius. Okay, so we're dealing with radius here. So I'm going to use this formula. C equals 2 pi r. So C equals 2 pi r. And the circle has a circumference of 24 pi. So I'm replacing C with 24 pi, which is a little weird, but that's okay. And that's equal to 2 pi r. I'm not going to change the r because that's what we're looking for, the radius. We are solving for that. So to get r by itself, I need to get rid of the 2 pi. It's essentially 2 times pi times r. So everything here is multiplication. So the inverse operation here is basically division. I got to divide both sides by 2 pi. So 2 pi divided by 2 pi is going to give me r on the right-hand side. And then I'm left with 24 pi divided by 2 pi. The pi's do cancel out, and then I'm left with 24 divided by 2. So that is 12. So the radius is 12. Now what I want to go ahead and do is talk about arc length. Now arc length is the portion of the circumference of a given circle. And remember, circumference is basically the distance around the circle, aka the perimeter around the circle. And we use 2 pi r or pi d to figure out how long or how big the circle is, right? I'm going from point A to point B. How long is that circle? Okay? This time we're dealing with arc length, the portion, like how big or how long am I going from point A to point B if I'm not using up all the circle? I'm only using parts of the circle. And let me go ahead and demonstrate an example using pizzas. So suppose that you have a small pizza and a big pizza. Obviously, these two figures are circles, and they both measure in 360 degrees, right? Again, that's not the circumference. Circumference and 360 degrees, they don't relate. Well, they do in some ways, but that's not what I'm trying to tell you, right? Like, how long is this circle here? We can use, lengths. We can use like centimeters, we can use inches, etc., etc., etc. That's what I'm trying to get at, right? So my goal here is to figure out, okay, if this is a pizza and this is a pizza, how long is this top part of the crust compared to this top part of the crust, okay? In terms of arc measurements, they're both the same. But in terms of arc length, obviously this crust here is smaller than this pizza's crust. And to figure out how long both of those crusts are, we have to use this formula, which is L, the arc length, is equal to x, which represents the arc measure in degrees, over 360, times the circumference, where we have 2 pi r. R is the radius. Now, let me go ahead and erase this. And then I want to go ahead and elaborate what x is. So x represents the arc measure. Typically, your arc measure is initially in... it's initially a central angle. That's what I'm trying to say here. It's initially a central angle, but remember the central angle and then its intercepted arc, their measures are the same. So if this central angle is 30 degrees, then the intercepted arc, in terms of degrees, it's also 30, okay? But I don't want you to understand that the arc length is 30 degrees because, again, we're trying to figure out, how long this arc here is in terms of length, in terms of centimeters or inches, etc., etc., okay? So, example 4 says, find the arc length L of the circle if R is 4, or the radius 4, and X is equal to 100. So, I'm going to use this formula. And I'm going to say, okay, L equals 100 over 360 times 2 pi, well, the radius is 4. And I'm going to rewrite this as L equals 100 over 360 times 2 and 4, which is 8. And then you're going to slap on the pi. I'm not going to multiply the 2, 4, and the pi together because I want my answers to look nice. I want to leave it in terms of pi, okay? So you're never going to multiply the pi ever. You're just going to slap it on, if that makes sense. And you're not going to include pi into the calculator. You don't want a very, very big decimal or a very nasty-looking decimal, if that makes sense. So, I'm going to get the calculator out. And this is what I'm going to do. I'm going to input 100 divided by 360 into my calculator, and you should get this decimal. Then you're going to multiply that by the 8, that whole number there. And you should get something like 2.222 and so on and so forth. Let's convert that decimal into a fraction, which is using the math button, and then you're going to press enter twice. And you should get 20. You should get L equals 20 over 9, but that's not the answer because we have to slap on the pi that we did not multiply in the calculator. And this is exact enough, therefore that's my answer. So that means that this here is 20 over 9 pi units long. And it's not going to be using degrees, right? Because the arc length, or sorry, not the arc length, the arc measurement is 100 degrees, but the arc length, the crust here is this units long. All right, let's go ahead and take a look at B. X equals 20, so L equals 20 over 360 times 2 pi 4. L equals 20 over 360 times, let's multiply the 2 and the 4 together, which is 8. So 8 pi, and I'm going to get the calculator out. And I have 20 over 360 times 8. Press math, enter, enter. Oops, there's an add. All right, so let me do that again. So I'm going to press math, enter, enter, and it should be 4 over 9 pi. So your length is 4 over 9. You slap on the pi, and that's your answer. All right, last problem. So it's L equals 360 over 360 times 2 pi r, which is 4. Notice that 360 over 360 is the fraction that I'm dealing with. That cancels, so I'm left with L equals 2 pi 4, or L equals 8 pi. So that means that this here is 8 pi units long, not 8 pi degrees. Okay? And there you go.